about Reflink. So Joe Becker is one of my colleagues from Oracle, and we promoted, we talked about Reflink in this February's the summit in the United States held by Oracle. So now I just give some updates about this. So here's the agenda. First, I will talk about some problems we meet with and why we want Reflink. And secondly is the solution. Is Reflink in OSF2. And the third part is about the status update. So first, I want to talk about OSF2 first. Actually, I wasn't work. I didn't work for Zen and virtualization. I just work for Linux kernel, and OCFS2 is Oracle cluster file system, and version 2. It is a file system in Linux kernel mainline, and it is integrated into Linux in 2.6.16. In our product, Oracle's virtualization, Oracle VM, we use our OCFS2 as a shared storage file system so that we can migrate and use images among many different machines. And so let's begin. Okay, so this is a problem we meant. So virtual machine, normally virtual machine wants first is snapshot, and second is clone, and the third is space saving. And as for normally we want to implement all this in our file system level so that from then or other virtualization environment, they don't need to worry about this type of things. And the solution is that we promote the system core to Linux kernel mainline, that is Reflink. So it accepts three parameters. The first is old path, the second is the new path, and the third is the reserve. So Reflink has the same calling semantics as CP. So, but create a new file that shares all the data extents of the source file. So normally a user, when the user wants to use the image and for different virtual machines, if he wants to isolate these two virtual machines, they normally use CP to cover two different images. But so if a file image is about 5G, the two same image will cost about 10 gigabit. So Reflink is just works like CP, but it isn't CP. It just creates a new file, but don't use any more disk space. But from user's perspective, it is these are two different files, but they don't use any file. I have some examples to explain it in some details later. So this is some examples about how to use Reflink. You see, the first is very simple. Just you are giving a host image and you want to, the snapshot is just replicate to another file, maybe a snap, and that's done. It's very simple. And normally, if you don't use Reflink, you must maybe need to copy host.image to host.image.backup or something else, and that you will waste a lot of space. And use this command. That's quite easy. And the second step is how to store it. You just remove the host image and Reflink back. Sorry, it's going to be. Yes, restore is also okay. But you can just move if you want to restore it. I guess move is also okay. So the third example is just how to clone it. You have a base image or something like a Go image or EL5 or something else, and you want to create a new image for another user. You just wrapping it to another image and just use create VM or something else to create a new host, or you may use then create or something else, but the semantic is the same. So this is how OCI2 implemented. So OCI2 is, just as I have said, OCI2 is a class file system and it's a modern file system. So it uses extent-based to store files. So it doesn't look like some old file system like extent2 or extent3. It is a very modern, so we use extend. So when we do Reflink, we just copy the extend, but not the disk images. So when you write to a Reflink file, you do some copy and write. As you know, copy and write is now very common for in Linux kernel, such as pages. This we use it. This time we use it for files. And the third benefit is there's no punishment for readers. We use external-based files, so as for read, they are the same external, just with different flags. So for read, it is normal and it's the same as a non-Reflink file. This is some examples. So see, let's give us an image that costs about 4 gigabit, and the df-h dot shows that the file system is /dev/sda9. It has about 100 gigabit and used about 4.2 gigabit. And CC and I do a wrapping to create a new image for this image. That name is UR5 _ U1 _ image. So you see the time it is almost very, very quickly. Okay, so this is this. You see that now we have two files. They both have about 4 gigabit from the user's perspective, but if you use df-h dot, you will see that the file system is still used about 4.2 gigabit, and compared to previous slide, you see the used space is almost the same, 4.2 gigabit. And you do a map empty file time. You see the read time is almost the same, and divide file time is the same. So this means these two files are the same, and the read has the same, the same system time. So there's no punishment for the reader, as I have said previously. Okay, so it's an example for write to a different image. The image I just replicated, it is just like something like you create an image, you copy the image, and you set up new virtual machine and write something in it. So as I just have said, it uses copy and write. So I just write about 1 gigabit to the Reflink file.